Let's look at adding new variables with mutate. So we've learned how to select all of our items in the data frame, how to move them around. Let's say we wanted to create a brand new function. And that's the job of mutate. Mutate always adds the new column at the end of your data set. So we'll start by creating a narrower data set so we can see the new variables. Remember that when you're in RStudio, you can pull up the data frame just by typing in the name of the variable. So we'll start with this line right here. You can pause the video and punch that into your RStudio. And then when you have that ready, you can see what the data frame looks like. You can see we have the year, month, day, departure delay, arrival delay, distance, and airtime. From here, we can use these columns to create brand new functions. So here I've used the mutate function to create a gain, which is arrival delay minus departure delay, and the speed, which is the distance divided by the airtime. Once you punch that in, you can see the two new columns added at the end, which is gain and speed. If you want to keep the new variables, you can use the transmute function. We'll look at that a little bit later in this video. But for now, we'll look at how to use more of the functions that you've created and create the variables you've created and create variables based on those new variables. So we'll pull our flight small data set and create the gain variable. We'll look at hours, which is just airtime divided by 60. And then we'll create a gains per hour, which we take the gain, which is a variable we just created, and divide it by the hours, which is also a variable we just created. When we do that, we get the gains per hour column. And so now you've learned how to use functions within RStudio to create new columns. When you want to create useful functions, there's no way to list all the functions available. There are many functions for creating new variables that you can use with mutate. The key property is that the function must be vectorized. It must take a vector of the values as input and return the vector with the same number of values as the output. So what that means is if you have 336,776 rows, that's how many outputs you'll need. So you'll see each value here. Eventually we'll get to 336,776. So when you're using arithmetic functions like the minus up here or the minus here, that keeps it consistent and easy to use. And you know that you have 336,776 inputs in the arrival delay and the departure delay. And so you'll have 336,766 rows of output. Another way to calculate these items is using the division. And that will also you have one input, and if you divide it by the constant, you'll get the same rows of output. So make sure to keep that in mind when you're using these arithmetic functions. Now I want to talk to you about modular arithmetic, which is it rounds down to the nearest whole number and it gives you a remainder. So the first item to look at is we want to calculate the number of hours, so we can use the transmute function. So you take flights, we want the departure time, and we want the hours of departure time, and we want the minutes of departure time. So first we do a modular division by 100, and that gives just the hours. And then we take the minutes and we do a remainder. So instead of dividing by 100, we take whatever's the remainder of the 100. And here you have your output. So you can see if you take 5 multiplied by 60, that'll give you, you take 5 multiplied by 100, that'll give you 500 and a remainder of 17. So there's your 17 remainder. So we've talked about arithmetic operators, modular operators. There's also logarithmic operators. They're incredibly useful transformations for dealing with data that ranges across multiple orders of magnitude. They also convert multiplicative relationships to additive, a feature that we'll come back to in part 4 of this course. All else being equal, I recommend using log2 because it's easy to interpret. A difference of 1 on the log scale corresponds to doubling on the original scale, and a difference of -1 corresponds to halving. So log2 is a much better function when you're using logs. There's also the offset. Those are lead and lag functions. That lead looks at the next row and lag looks at the previous row. So that's how you use lead and lag for the offsets. There's cumulative and rolling averages. We'll look at those in the next video. Those for group bys and summarizations. And then there are logical comparisons, which we've already talked about. So go ahead and use the data set and take the items that we learned today and see if you can create brand new functions that you can use in your data frame. In the next video, we'll talk about group by and summarized functions.